Good afternoon, everyone. I am Steve Linscomb with USA Rice, and it's my pleasure to welcome you to the California Rice Research and Outlook Report. Our reports this afternoon are sponsored by National Rice Company, and a short message from the company. It has been National Rice Company's honor to support the U.S. rice industry for over 115 years. On behalf of the 4 generations of our family business, we extend our best wishes to you and your families. Thank you, USA Rice, for your work in offering these sessions, and we look forward to gathering in person as soon as possible, hopefully at least by next year. These reports typically are part of the Rice Outlook Conference, which is held each year about this time. Certainly, we couldn't have an in-person meeting this year, but we felt that it was important enough. The information presented in these reports were of such value to the industry that we would provide them in a virtual format. Our speaker today will be Dr. Bruce Linquist, who is Extension Rice Scientist, both research and extension work conducted at UC Davis. Bruce is very well known, not only in California, but throughout the rice industry of the U.S. and actually beyond the borders of the U.S. And he is certainly a very valuable asset to the U.S. rice industry. I would like to make everyone aware that this session is being recorded, and by early to mid next week will be available on the USA Rice YouTube page. And again, if you've got any questions, just enter them in the Q&A icon down at the bottom of your screen. So with that, Bruce, I'm going to turn it over to you.
Thank you, Steve. Let me just share my screen here. Can people see and hear that?
Yeah, we can, Bruce. Perfect.
Okay, thank you very much. Just want to thank you all for joining this afternoon. I realize it's a Friday afternoon and looking forward to a weekend. But thank you for joining. And again, just want to thanks to the National Rice Company for sponsoring this. So I'm going to be giving both the Outlook and research reports today. And so I'm going to kind of go through both of them and you can have questions at the end. So jumping right in, this is a graph of our planted acres over time. And you can see that we have this year, 513,000 acres. We're typically about 20% of the US rice area. That holds pretty much true for this year. We're a little higher than we have been in the past couple years. Our fluctuations in area have a lot to do with water. You can see back here in 2014-15, these were years where there was significant drought. And then we had another low acreage year here where there was a lot of rain and we didn't have time to plant. I like to show planting progress. It just kind of shows kind of where we are in a season. And you can see here, I kind of focus a lot on the 50%, when 50% of the area is harvested. You can see a very wide range in planting from early, end of April, early May, all the way toward the end of May. And this is 2019 or 2020. We were about a week earlier than we were last year. This is 2019 over here, around May 4th. So this was a earlier planting than normal. And that generally bodes well for us. It suggests a dry spring and good, a lot of time for land preparation. So we had an early start. This is just kind of another way to look at it over time. And you can see this is since the late 90s, but you can see here, this is about a May 7th, 50% planting progress. So a little earlier than we typically see. Also using USDA data, we can see the 50% harvest date. And again, early planting translated into a little earlier than normal harvest time. So about half our acreage was harvested by around October 4th. And then just looking at subtracting those two to kind of get a season length, we like to see a season length of around 150 days. And that's kind of what we ended up with this year. We sometimes get very long seasons, and this is usually due to a lot of rain during the harvest period. So earlier than normal planting, but similar season length is good for us. So just to kind of summarize some of the key points of the 2020 season. Again, I just highlighted the early planting due to a dry spring. Really the primary COVID issue that we had, didn't have much, but the aqua ammonia supply was limited for about a week early in the season. Aqua ammonia is the main fertilizer source used for rice. And so a lot of growers either delayed planting a little bit or they used different nitrogen sources, a common one being liquid urea. This year we did have a lot of blast especially in the northwest region, kind of up in Glenn County, coming down into Colusa County. This was primarily a problem on M205 and M209. We have had problems with armyworm in the past, but this year it was not a problem. Wildfires, smoke late in the season. I'm going to talk about that in a little bit. We had a very dry harvest season, so this was very good. It allowed people to harvest without necessarily rushing. However, this dry period is continuing, and we'll talk a little bit about that later. But also with that dry, there was 2 periods during the harvest with very strong north winds, and growers saw their grain moisture drop several percentage points over a 1-day period with these winds. And that led to some lower milling grades on some of the rice harvested around that time. Overall, our yields are going to be about average, but I think our milling quality is going to be a little bit down from what we're typically used to. And if I had to guess, this is kind of the historical yields over time. I'm guessing we're probably going to be around 85 sacks here in 2020, which is kind of what we've been bumping around for the past few years. Just wanted to touch on those wildfires. It was a big story here in California. It certainly limited some operations. It was very unpleasant to be outside doing a lot of outdoor field work in that area. What we saw though, this smoke, these fires occurred primarily during grain fill and ripening of the rice. So we had some fires a few years ago, and it was about 2 weeks earlier than this. And I think that's kind of falling in kind of between PI and heading. And I think smoke during that time with the limited solar radiation really limited some yields in certain parts of the valley. But I don't think this year it had a big effect. You do see here these 2 periods of heavy smoke. This dark line here is kind of a normal year of solar radiation. We do get less solar radiation with time just because the days are shortening. But you can see in some of these days, especially in the northern part of the valley, Durham and Williams, we were getting 2/3 of what we normally expect on a normal day. But again, I don't think it had a drastic effect on yields. It may be a factor in quality, and it may have helped with, we had a lot of blast, and with the smoke in the air, there's more dew and moisture that kind of sticks around the plant leaves, and that may have led to some increased blast during that time. We run a yield contest every year, and this year was no exception. And just for those of you who aren't familiar with that, we harvest a minimum of 3 acres, and usually it's about 4 acres. Our yields are adjusted to 14% moisture. We divide up the area into 3 different regions. Here you see 1, 2, and 3 divided by Highway 20 and the Sacramento River. It just allows, we feel that there's different yield potential between these different areas, so growers are competing with growers with similar yield potential. And the winner from each of those would draw us for a gator. This year, we had a fewer number of contestants than we normally did. And again, that's partly due to COVID. Usually most of our contestants come during the field day, and we had a virtual field day this year. But still, 13 contestants was good. Just the varieties that were entered, 2 of them were M105, 1 M206, a lot of M209. It's a good yielding variety. And then 1 M211. I'm going to talk a little bit more about that variety. It's a very high yielding new variety that's just come in. Yields ranged from 101 to 128 sacks. And just found out, really finalized the winners today. We got their grade certificates in. And so these are the winners from each of the different regions. In the Northwest region, Gary Enos got 111 sacks, and that was with M209. In the Northeast area, this is in Butte County, Eric Slager got 127.9 sacks, and this was with that M211 variety. And then in the South, Greg Driver got 123.5 sacks, again with M209. And these growers will be drawing for this gator up here during the upcoming winter grower meetings. So we get a chance at that. And I just want to thank the sponsors listed there for making this possible, and thanks to the entries that we got in here. We learn a lot from these yield contests. I'm not going to share that with you here, but they're very useful in helping us in our program to really look at how do we get some of the high yields that we'd all like to see. Just want to mention one other thing that's really kind of shaping the California landscape that's changing a lot, and that's the amount of rice straw baling. You're going to see a lot of rice straw being baled up and down the I-5 corridor. And this is really, I think, accelerated over the past couple of years. Part of the reason is we've had some very dry falls, and which has allowed for a lot of straw harvest. I'm not sure in a wet fall year how much straw baling we would see, but certainly in this past year, there's been a lot of it. One of the reasons where a lot of the straw is going, particularly further up on I-5, is a new fiberboard plant that's making fiberboard from rice straw, this MDF board, which is going to replace particle board. This plant has just really started production within this last month, maybe even within the last week. It's just starting to kick out fiberboard. But it anticipates getting straw from about 100,000 acres. So that's 20% of our acreage. So that's going to have a huge effect on nutrient management, winter flooding, perhaps waterfowl. So it's things that we need to think about. Also, just further south along I-5, there's a lot of rice straw going down to for the dairy industry, partly used for feed or for bedding down there. So that's something that's really changing and something we need to keep our eye on. The outlook, a lot of our rice acreage is driven by water and water availability. And it's very early in the year or late in this year, but early in, to determine, you know, what our water outlook is really going to look like. But I would say so far we're very dry. And if you just look at some of the data from CDEC, our reservoirs are about 2/3 of normal for this time of year. Rainfall is about 1/3 of what we typically see by now, and the snowpack is about 50% of normal. So hoping for a lot more rain coming up, but right now it's dry. Okay, I'm going to shift into research. And I'm going to say right out the front here, this last week we had the Rice Research Board meetings, and so I'm pulling a lot of slides from those meetings that we've had this last week. And so I've had to try to, over just the last few days, just try to pull it all together. It's very broad what I'm going to be talking about. I'm not going to try to give you a lot of results. There's a few scattered through here, the results. Some of the results I couldn't give you, maybe I don't understand it enough, but I'm really trying to give you a sense of the breadth and the type of work that's going on. I do it where I think in most cases provide, you know, the person that's doing the research. If you want to contact them about more details, you'll be able to see that. So again, just providing breadth and kind of an idea of the type of research that is going on. So I'm going to start off with breeding and genetics. Oops, sorry. And much of this is occurring up at the California Rice Experiment Station. And just want to let you all know that there's been a change in leadership up there. Dr. Kent McKenzie, who's been director up there for many years, is transitioning out and will be retiring this month, I understand. And Dr. Russell Rasmussen is taking over. He's been acting director or sharing directorship with Kent during this year. So there's been kind of a year overlap during this past year. So we look forward to working with Russell. Kent does plan to stay on in a role mostly focused on just making sure the ROXY production system, seeing that through to completion. And I just wanted to highlight too, they've got a large team of scientists working up there, Boots and Teresa, Shamal, Cynthia, all based up there. And Tom Ty is a USDA scientist doing some genetics, but he's based at UC Davis. And they've got a lot going on, but really what I'm going to just share here is some of the highlights of some of their newly released material. And in short, these new varieties are all performing very well. S202 is a high yielding short variety. It was just released in 2019, and it's been doing very well in the yield tests that we run statewide, out yielding S102 consistently. I'm going to jump down to L208, which is another very high yielding variety with good quality, and it's for the long grain market. Again, we don't grow a lot of long grains here, but L206 and L207 have all had very high yields, but L208 is even out yielding those with good quality. So it's a good, for those growing long grains, it's something that's very good. M211 is a very new variety. This year, you saw it in our yield contest, high yield, but it was only grown in seed production fields. It wasn't available broadly commercially. This year it will be. It's an early maturing Calrose variety with very good taste and cooking quality, very similar in some respects to M401, which is a premium variety. So good quality and very high yields, out yields M209 very consistently, and the other ones by about 4 sacks across much of the valley in the warmer areas where it's grown. It's going to be more targeted toward the warmer areas of the valley, kind of a little bit where 209 is grown. But there's one caution here. It needs to be grown a little bit differently, at least harvested a bit differently. And this is just some data looking at head rice yield of that variety. This is grain moisture content along here, harvesting at different grain moistures. And this is the head rice yield. M206 is very stable across a wide range of harvest moistures. You see this M211. Once you get past 20%, 19%, it really starts, the head rice yield really starts to drop off. So growers wanting to grow this need to be aware of this, that you need to harvest it a bit earlier. Drying costs might be a little higher. I don't know how it's going to work in large production systems where you have thousands and thousands of acres and being able to harvest it all at the right moisture content. But that's something that needs to be worked out. But very positive on this variety. I think it'll fit well into our system. Just wanted to wrap up the breeding and genetics with this ROXY rice production system. It's in a partnership with Alba, and I'm not going to go, there's a lot of text here. I don't plan to read all this, but it's a non-GMO trait using the herbicide oxyfluorphan to control weeds. And Kent's been working with Arba along with Kasim to develop this system. And we see it's a different approach to tackling weed problems. Weeds are a huge problem. Susceptible weed, herbicide tolerant weeds are a problem. And I think this program will go a long ways in giving growers better tools to address some of those problems, as well as the weedy rice issue. So they're looking forward to launching this rice production system in 2023. So you can look forward to that. The varieties that it's been put into, M206 and M210, those have been yielding very well in our variety trials. So the yields of this should be comparable with what we're seeing for these M206 and 210.
Bruce,
I'm going to jump into pest management.
If I could interrupt you just briefly, we did get a question.
Yep.
On blast susceptibility of M211.
I do not believe it's blast tolerant. I could be wrong, but I'm pretty sure it's going to be susceptible to blast.
Thank you.
Yeah. Pest management. There's a lot of people working with weeds, but the two key players really are Kasim Al-Khatib and Whitney Brim DeForest, both with UC. A lot of work going on resistance, looking at mechanisms of resistance and spread of resistance in the valley. A lot of evaluating programs and new compounds. Non-chemical approaches to weed management and weedy rice are all part of this program. In terms of herbicide resistance, Kasim runs a program. I mean, he's doing a lot of studying of the mechanisms, but a program for growers that's very good, I think, and valuable to growers is growers can send in seed that they think is resistant to a herbicide. During the winter, these are tested for resistance, not only to the herbicides the grower had thought was an issue. They test it for all herbicides, and then they'll give them a sheet at the end that shows what it's resistant to and what herbicides actually can control that weed. So a very valuable program and a lot of work, but it's a very valuable program to the industry. There's a lot of new herbicides coming out, new modes of action. I'm not going to go into all of this. Loyant was perhaps the most studied herbicide this year, at least by Kasim. And there's just some pictures here of some of their trials, but you can see Loyant has control for barnyard grass, rice flat sedge, duck salad, red stem, monocoria, arrowhead, and water hyssop. So Kasim has done a lot of work on that, and in his winter grower meetings and in the Rice Research Board reports, you'll be able to see the various programs and how it's used to develop that type of control. Weedy rice is an issue that really raised its head 5-10 years ago. And it's been a big issue for us here in California in dealing with, and certainly potential headache for a lot of growers. Right now, all growers are required to use certified seed, plant certified seed, as due to this weedy rice problem. And I would say, just talking with Luis, Kasim, and Whitney, growers that have had it in general, when they're aggressive at controlling it and trying to control it, they've seen it getting reduced. And so we're not seeing rapid spread. And where growers are really aggressive, there's been some good control. So again, there's now 7 biotypes and various field research to manage, to help manage this weedy rice. We're monitoring populations, developing stale seedbed technologies, looking at crop rotations as potentials for this, looking at herbicides. This year, Whitney was looking at suppress to see how well it did, looking at germination and emergence in relationship to temperature and rice and seed bank longevity. So a lot of research going in to developing ways that we can control this and keep it to be, at least get it, that it's no worse, and hopefully growers will be able to deal with it once they've gotten it and get it out of their fields. There's also another unknown watergrass species that really became visible in about 2017. And it's in fields where it's at, it's a big problem. And so Whitney is a lot in charge of this. They've collected 10 populations for herbicide screening. You can see some of the results here. This is just an example. They've done a lot of studies. And I would say this is very preliminary. They wouldn't want this to be considered, this is what it is, but they need to do a lot more testing. But early suggestions that preliminary results suggest that early granular herbicides are not very effective on this weed. And they're also working a lot just to find out what it really is. So their genetics are really need to properly identify it. And so they're working with other groups to try to do this. For our invertebrate pests, Dr. Ian Grettenberger and Luis Espino kind of take the lead on that. A lot of their work is focused on tadpole, shrimp, and armyworm, a little bit on rice water weevil. Water weevil, the populations have seemed to have gone down for various reasons over the past decade. We see relatively low water weevil infestations. So there's been a little less work done on that, although they do continue to do research in that area. Tadpole shrimp has been an issue that has really increased over time in our water seeded systems. And so there's been both Ian and Luis do a lot of work on this, looking at different pesticides that can control it. Application. Luis is doing a lot of work on just looking at the stages where tadpole shrimp are most destructive and relate that to the stages of rice and temperature. So they're getting a pretty good handle on how to handle it, but it is an increasing problem. And again, looking at a lot of pesticides that many of them showing some good effect on tadpole shrimp. Armyworms, again, are an issue for us. Really became a big issue a few years ago, but it's a problem in various parts of the valley pretty much every year. And so Luis runs a program where they're setting out traps around the valley. They have a number of these stationed all over the valley, looking at peaks of where they're seeing increased flights of the moth. And you can see that generally during the growing season, we see two different peaks. The peaks vary sometimes from year to year when the peaks actually occur. And they're doing a lot of research just to try to find out how do these peaks relate to when we might see potential damage, and trying to alert growers to when they might need to be either scouting for armyworm or thinking about putting on some sort of pesticide for control. And again, just looking at some potential damage that armyworms can do with some defoliation trials conducted. Again, this is just an example of the work, but you need a fair amount of defoliation to take a significant cut in your yields, as shown here. Also related to pests, Dr. Zhongli Pan at UC Davis is looking at monitoring insects in stored rice, and they're developing wireless systems where you can put them into the rice, and it shows you in real time insects coming in, and it also gives you other information, humidity, temperature of your rice stack. So good promise in this technology, and I think it's a technology that I think a lot of folks involved with rice storage are going to be very keen about. So they've made good progress in this area. Luis Espino does a lot of the work on diseases. Again, we have a lot. Disease is much less of a problem for us here in California than experienced in the southern U.S. Stem rot and aggregate sheath spot are our biggest diseases, and they're around pretty much every year. Kernel smut became an issue a few years ago, when it was really bad, maybe 2-3 years ago. Since then, we see it, but it's not been as bad as we had seen it in the previous that 1 year. I think it was 2018 or 2017 when it was really bad. So Luis is doing a lot of fungicide trials, looking at chemicals, different rates, and particular different timing to control a lot of these, looking at varietal responses to kernel smut. M209 is a big problem. Some long grains are a problem with kernel smut. And then looking at the effect of bleaching on kernel smut. In California, in our water seeded system, we bleach the rice seeds, soak the seeds in bleach for a period of time before planting. The bleach is controlling bacony. There was interest to know, is it also helping control smut? This is just some examples of some of the trials. Again, looking a lot at different, this is for stem rot and aggregate sheath spot, different chemistries and different timings for both of these. So again, details of this can be found in his reports. Kernel smut, again, looking at where it might become a problem. And they found pretty much that about at 2%, if you have 2% of your kernels with kernel smut, you're going to start to see a yield reduction in that due to kernel smut. So they've been developing that critical range. And then just the effect of bleach. They looked at a couple different varieties collected from a heavily infected field. And you can see here that the bleach treatments there was no effect on smut germination. In fact, if anything, it was slightly worse. So there's no evidence right now that our bleaching the bleach that we use for soaking the seed early on benefits us in terms of kernel smut. Going to jump into rice culture. This is an area that I'm involved in, and I do a lot of work on remote sensing capacity. A lot of my work recently has been to use remote sensing, green seeker, or drones to determine if we need to apply top dress nitrogen. We're looking at early season N losses due to denitrification primarily. If you have a wet soil or if your field drains for some reason, how much nitrogen are you going to use? Look at different alternative N management options when aqua is not available. Also looking at how to manage nitrogen to help reduce lodging. We've done some planting date studies, looking at alternate wetting and drying and mid-season drains and land use changes. There's a few limited results here. I mean, this is work we've been doing for quite a number of years, but using the green seeker and developing a response index, we're able to predict fairly well when you're going to get a positive yield response. And if your response index with a green seeker is above 1.1, there's a good chance that you're going to see a positive yield increase on the order of anywhere from 200 plus pounds an acre in response to about 30 units of nitrogen. We're seeing that same breakpoint 1.1 with the drone work that we're doing. And this is using a slightly different, this is NDRE instead of NDVI, but the breakpoint is very similar and the responses are similar that we're seeing. So good tool, I think, for growers to take some of the question marks out of should we be applying top dress nitrogen or not. But these tools, about $800 for a green seeker. Looking at response to nitrogen management, M105 is one of our highest yielding varieties, but it seems to lodge a lot, or a lot of growers are not growing it because of its propensity to lodge. So we wanted to see if we could do better nitrogen management to reduce lodging. And what we actually saw, this is our total N rate, and this is canopy height. This is the height of the canopy above the soil. So if it's down here, it means it's really lodged. It's about 15 inches from the ground, the top of the canopy. Our rice here is, this is pretty well good standing rice. So with increasing nitrogen rate, as you'd expect, we get more lodging. What we did see interesting is these dotted lines are where we applied a top dress. Applied at the same total N rate, top dressing seems to encourage lodging, which is a bit of a surprise, but more importantly, we saw the M206 down here lodged more than M105. And so this is something that kind of surprised us because we were thinking that M105 was lodged more. So it's going to be something we look a little bit more at in the future. And then just looking at the amount of nitrogen that is potentially lost if you have early season dry down events. These dry down events may be due to, if you're dry seeding a field and you're flushing and drying, this is what we do here in this graph. Or sometimes a levee breaks and you lose all your water and you have to reflood. We're trying to find out how much nitrogen you lose, and how much nitrogen you lose is really related to how much nitrate accumulates during that dry down period. And what we're seeing is over a number of sites, I'm just showing one here, but we're losing about 20 to 30 pounds of nitrogen per acre in when there's two dry down periods. So if you're drill seeding and you're doing this, that you're going to have to apply that much more nitrogen to make that up. So we're trying to find out how this varies across different soil types. And another thing that I'm looking at is just how California rice systems are changing. Again, it's very different from the South. A lot of our rice area is pretty much rice only. There are areas where it's rotated. And so we're using satellite imagery and to track changes over time. This is just kind of an example of what we're finding. But over the last 13 years, about 30,000 acres of rice, of land that had been in rice or had grown rice, has converted to almond or walnut. And so this would be somewhat of certainly a longer term change. I mean, you plant walnut and almond for 15 to 30 years. So it's taking it out of rice. We're also seeing that crop rotation in general is decreasing, but fallowed acres are increasing. This might be due to water sales in dry years or in wet years when you're not able to apply that. We're just looking to see how this varies across the valley, how it depends on soils, and maybe the cost of water and economics. Cameron Piddlecow, a new faculty member at UC Davis, is kind of looking at some of these rotations, not with trees, but with field crops, really to look at the effectiveness of rotations in addressing weed management issues. As you saw earlier, resistant weeds are a big problem, and so we're seeing how crop rotations might fit into this. So a lot of his work this year was just in interviewing growers to try to find out what they're already doing, what factors influence their decision making, what are they finding works and doesn't work, and then trying to quantify where crop rotations are really practiced. Is it related to soil or experience or that type of thing? So it's something that he's going to be continuing to look at to see if that can be a better utilized tool in managing weeds in problem areas. Another area that is that is interesting is some work that Kasana Savakarev is doing. Also a new scientist at UC Davis, does a lot of work with evapotranspiration and really looking at quantifying water use in cover crops that are in rotation with rice. The impetus for this study is that cover crops are often grown with rice and can have multiple benefits. But the focus here is the benefit in terms of providing habitat for waterfowl. If cover crops are terminated early, and like early being like March, April, and then put into another crop, what you're doing, a lot of birds have laid their eggs in the field. And when you terminate the crop and till it in, you're pretty much destroying the eggs. So they're looking at how much extra water, if growers are going to be incentivized to keep that crop in the field, maybe until July, how much extra water would be used during that time? And is there any way to provide incentives to growers to do that? And certainly water is the big issue, and keeping land out of production is going to be an issue. So this is kind of getting at the heart of that. So she just started her first year this last year, and will be continuing this year. Out of Chico State, they're looking at seed vibration treatments to enhance germination and early season plant growth. These are Dr. Connor and Dr. Lyles. They've been working with Lundberg Farms, looking at vibrating seeds early on. And what they've shown is that they have shown that you do get faster germination and you do get faster early plant growth. You actually get more germination as well. This hasn't translated to higher yields in the field. And so that's what they're really focusing on now. The last section that I'm going to be covering is sort of the utilization of rice straw and hull. Again, I already mentioned the big fiberboard plant up in Willows that's producing this type of fiberboard, but there's a lot of other research going on to see how these products can be utilized. Joe Green, also at California State University up in Chico, looking at using these to make automotive headliners and plastic bags from these straw products. Closer to home, she's been working, getting funds from the Rice Research Board for quite a while, and developing some very interesting products, very unique products that really can only be made with rice straw, in terms of nanomaterials, various aerogels and this type of thing that show a lot of promise, have certainly shown a lot of promise in the lab. and they're working to try to get this more into the industry. But a lot of interesting work that she's done. And then some interest, and there's been quite a bit of interest in this over the past, about using ash for concrete as a replacement for slag in the concrete. The ash strengthens the concrete and shown to do it quite well. And so Savvy Miller and John Harvey with UC Davis are looking more at the feasibility of this. Do we have enough rice straw to do this? Does it make sense to do this? And what would be, how much ash is needed and that type of thing. So they've been funded for a number of years now to kind of sort this issue out. And with that, I'd like to thank you, and I think I've wrapped up my talk. I just wanted to again thank the Rice Research Board. All of that research that I've just presented, or the bulk of it, has been funded by the Rice Research Board, and we all thank them a lot for the research that we're able to do, and we certainly hope it benefits the rice industry. So thank you.
So Bruce, again, thank you. That was excellent. I learned a lot, especially on some of the uses of various products coming from rice. If anybody would have a question, please type it into the Q&A box. I've actually got one or two here that I'm very curious about. If I might, you mentioned drill or dry seeding. How widespread is that in the California rice industry? Is it growing? Is it, kind of sideways? Got a few people doing it. I'm just curious about that.
It's very small. I would say less than 5%. But I would say, I think it might be growing a very little bit. But it's certainly not much. But I think it probably has increased a little bit over the past number of years, but still in the single digits in percentage wise.
You also got a couple of comments, great presentation from the audience. I'm also curious, if I might, how your salmon rearing project in the rice field is going.
Yeah, we're actually going to have Paul Butner talk about that at our upcoming grower meetings. It's positive. I mean, there's a number of fish projects going on in rice systems. There is the one where the fish are being raised in the rice fields that are relatively close to a canal where they can get out into the Sacramento River. And then there's other fish projects that also, I think, geared towards salmon, where during the winter, fields that are flooded, they release the water from the fields into the Sacramento River. That water from the rice fields contains a lot of good food for fish. And so there's programs, certainly down in RD 108, that are working with growers to have a steady stream of water release out into the river to be providing fish food in the Sacramento River for those fish. So there's 2 or 3 different programs that the rice industry is working on that are to benefit fish.
We got a couple of questions related to your milling yields. One participant said, we've heard reports of low milling yields this year, and what do you think caused this? And a related question was, how are head rice yields in the medium grains this year?
Well, the milling yields, the head rice yields, a lot of it is dependent on when they harvested. Early in the season, before those north winds, we were getting fairly good, fairly typical head rice yields, up in the upper 60s. mid to upper 60s. But then when growers started, they got those north winds, and when the moisture in that grain drops so rapidly, it really negatively affects head rice yields. And we see it in our yield contest, but just talking with growers, it was bringing it down into the 50s. Sometimes even the low 50s we were seeing for head rice yields, which is not at all good for us. So when the rice was near harvest moisture, around when those north winds occurred, and then they had to wait, or they were harvesting through those north winds, growers saw some really low head rice yields.
So Bruce, I've got one final question from my end. I'm curious, you mentioned on the M211, improved taste, and I think you also mentioned it was approaching M401, which I think is considered one of your premium quality varieties. I'm just curious, how is that analyzed? How is that a Century panel that evaluates for the taste, or is that just a group perhaps at the Rice Research Station that evaluates?
We had this discussion yesterday. I said, I'm going to have to talk about M211. And you guys are calling it a premium. And I'm saying, how do you do that? There's a lot of people that know a lot about rice that say it's premium quality. However, right now you get a premium price for M401. My understanding is that the breeders at the station are going to work with a group to establish if it is indeed a premium quality rice. Otherwise, it's just going to get commingled with other medium grains. So they are working on that. That's why I didn't want to say that it was a premium quality, but they are certainly going to be seeing if it can be put into that market.
Well, excellent. Thank you very much. And again,
does that answer your question?
It does. It does. We've had the same, when I was a rice breeder at Crowley, we had some of the same, I guess, what you would call challenges. So yep. We very much appreciate, Bruce, you did a great job. This was excellent. We appreciate everyone that has participated this afternoon. And again, we want to express our appreciation to National Rice Company for sponsoring today's session. With that, I would like to wish everyone a great weekend, and hopefully in the not too far distant future, we can do this live again. Thank you very much.
Thanks, Steve. Thank you all.